Welcome everyone to this session. I'm going to talk about how we at ABN AMRO Clearing use Tableau to visualize our machine learning output. But first, something about myself. So this is me. My name is Marleen. I studied mathematics at this beautiful University of Münster in Germany. And then, because of love, I moved to another beautiful city, which is Amsterdam. And there I started working at ABN AMRO Clearing. At ABN, I'm a quantitative risk analyst, but I'm also a data steward for our risk data. And the last years, I started using Tableau a lot, and I'm really happy about it. So not only do we have, I just came from a session about the Center of Excellence, so not only did we implement the Center of Excellence, but also the proof of concept, so really from A to Z, the whole process of implementing Tableau. Yes. And my session will be about, I said it before, how we at ABN use machine learning. So this first of all, to give you a quick introduction, because then I think it makes much more sense to show you the dashboards. And then within machine learning, the basics of a neural network. And then also our setup, the big data with Tableau together. And then I will give you a demo about our machine learning output dashboard. What is ABN AMRO Clearing? So what we do is we clear trades of companies, around 16 million a day, and that on 90 world-leading exchanges. So we have a lot of data. I myself work in the modeling team, so where you can find that within the organization is you have the bank itself, then within the bank there's corporate banking, then there's clearing, and then there's risk, and I then work in the modeling team. So what does modeling do? This is a question my mom always asks me. What do you actually do? So our tasks are, we specify models. For example, clients want to trade new products. We don't have the correct model yet, so we specify them, then we prototype them, usually in R. We backtest them, and also we have to validate them once a year towards an independent model validation team. We also have fire drills from exchanges where they want to see that we are prepared for clients being in default. And we have model support. So our main users are risk managers all around the world. So whenever they have a problem with the risk output, they would contact me in this case, because I'm the dedicated model support person. They would contact me and I will have a look into the report and maybe check if I can fix it myself or if I need help from other people. And then next to this, also data maintenance. So most of the support issues we have are related to data maintenance issues. So we try to set up as much as possible so that we don't have too many support issues. Our main risk model is a correlation haircut model. I don't want to go into depth, but we use it for all our asset classes. So our clients trade all asset classes basically, and we use a correlation haircut model for all of them. However, they are flavors per product. For this model, we need a lot of data, not only the data of our clients, but also additional data to enrich it. For example, if you are maybe familiar with options, if we have like an option series, our clients only trade a few of them, we need to enrich the data in order to get correct risk output and to price the options and then to also calculate the risk. And this then for other products as well. So our data maintenance is really huge. And if we put wrong data into the model, of course we will have wrong output. So in the past we used a lot of Excel, Access, also R to do some data checks. We also had some kind of semi-automated checks in Linux, and then also of course we used VBA. But we also had many requests for IT in order to get the data and in order to do a data check on it. And what we always did is that we defined a rule. So we said, for example, we get price data, and we say, whenever price is 0, show us this product, and then we try to fix it. So we define rules. And now I want to give you an example of what I mean with bad data or wrong data, which will be then the input to our risk model. So here on the x-axis you can see time, so this is one trading day, and then on the y-axis you can see the price of all products together. All the red dots are wrong data for whatever reason. You see that my rule, which I just explained, like give me this record whenever the price is 0, doesn't hold here because the red dots are everywhere. So it could be that, for example, a product is actually priced with a price of 30. However, in here it got a price of 40, which is wrong. So we need to detect them. What we did in the past is that we defined rules and made them more specific. For example, we said, okay, it doesn't hold on the whole data set, but then we will put them into categories. Here you can see that this price data is categorized per exchange. So in the second column you can see there we could make a rule like, show me the price if it's higher than X for this exchange, because then it will give us all the anomalies. So all the red dots are anomalies in this data set. However, for this exchange, for example, it doesn't hold. Neither does it for this one or for this one. So probably here we would have to categorize them again in a different way. For example, based on time, maybe based on a contract size. So we will end up having so many rules, and every time a new problem will pop up, we define a new rule. So what we did was, we talked to a machine learning student, and he actually said this. If you use machine learning for this, data checks, it will solve your problems. You don't have to define rules anymore. So his promise was he could implement a deep learning model, and deep learning deep learning will be able to learn patterns in a big data set, because what I said in the very beginning, our data sets are really, really huge. So this was one thing we really had to have, so large amounts of data. But then also, even if you are not an expert, it will show you the anomalies. So you don't have to define rules, because it can approximate theoretically any function. So within deep learning, I just want to give you an overview on where we are. So here you see machine learning, then you have unsupervised and supervised learning. We use unsupervised learning because we don't have labels. We don't label the data as an anomaly or not. We just want the machine to learn by the data set itself. And then within machine learning, we use dimensional reduction, and then within that area, we have a meaningful compression. And I will explain now the basics of this very quickly so that you can understand the dashboard later on better. So this is a neural network. You can see here the input. So for example, if we use a price file, then this could be the price of the product, the symbol of the product type, the quantity, the exchange, and so on. So each circle in the input is basically a column header on an Excel sheet like we all know it. Then something happens, which I will explain in a minute, and then we have the output, and then the input and the output will be compared, and the difference of the two will be the this MSE error. So this is what basically happens, and now I will go a little bit more in detail. So this slide is now the first and the second layer. So what you can see is that each circle, which we call feature, each feature is connected to each circle in the next layer. All of them are connected to, so each is connected to each. then what happens is that all of those will get a weight and will define this one. So what happens here is actually 2 times 1 plus 2 times 1 plus 2 times 0.1 plus 2 times 0.5 plus 2 times 0.5 is 6. It is not as easy as I put it here, but you can assume that this is basically how it works. So this happens for all of them. So we go from this layer to this layer, then again we'll define this layer, and this is actually the latent space, so the most compressed information, and then we will decompress it again back to our output layer. And then this one and this one are exactly the same, so the mean squared error will be 0. So it is good. What I now have to say is that we do this for each row of the data set. So this is one row of the data set, but then we do the same for all the other rows, and the weights, which you saw in the previous slides, have to be the same for all of them. So this is then the optimization problem. So we define a loss function so that we have the minimum possible loss on the weights for the whole data set. That means in the end we will get a mean squared error per row. The higher the error, the more likely it is an anomaly. The lower the error, the more likely it is correct data, so not an anomaly. So what we saw before, the 2222, were in the end again 2222, so the error was 0, so it is not an anomaly. The output will look like this, so that you have here the row ID of the data set, and then you will get the error. It is sorted by size, obviously, because you first want to see the anomalies, and then the normal data you are not that interested in, right? Because that is just normal data. But this is all very theoretical, so let's go to an example. Let's say we have a data set of zebras. Many pictures of zebras. Then we have our neural network, and we will put the data set with the zebras into the neural network. So now the features could be, for example, color, size, teeth, ears, whatever. So this is now then the input. This will go through the data set, and because we have so many zebras, the model will learn only from zebras, so it will be really good in compressing and decompressing the picture of zebras. So zebras will be input, zebras will be output. Now we will take one horse. It is similar, but it's not the same. So if you put one horse in a data set with a lot of zebras, it is an anomaly. So what do you think happens to the horse? Yes. So the horse will be something like this, most likely, because the model learned from zebras and only one horse. So it is not really good in compressing and decompressing a horse. So this is what happened. Those two will be compared, and this error will be bigger than the one between those pictures. So now we have the output. So where in here do you think the horse will be? Top, bottom, or middle? Yes. And then the zebras will be somewhere lower down the scores because they are normal in our data set. And then in between, there's something else. So we did a proof of concept with this model, and we had really good results. So on 10 days in a row, we entered 0.01% of anomalies in a data set. So we defined that there were anomalies because we put them in there. And we used a data set of around 300,000 records. And on each of these 10 days, the first 40 scores we saw in the data set were actually the anomalies we put in the data set. So that means, I try to visualize it a bit. So we have a data set, normal data set with prices. We enter some anomalies in there, so we change the price of this data of a few rows in the data set, like 80 I think it was. We put it through this deep learning model in the neural network. We will get the scores, and on top of the scores there were exactly the anomalies we added artificially in the data set. Then there were a lot of the normal data, and some of the anomalies were also still in here. However, what we wanted to prove is that if a user looks at this, that there will not be false positives in the beginning of the scores, because then there will be no trust in the model, because then the people will say, yeah, but the first 5 were false positives. If I do this every day, I lose a lot of time. Why would I do this? So this is exactly the reaction we had. So yeah, that's really nice that you come now with your proof of concept, but we don't believe if you just see a score, what should I do with it? Should I then just change the price because you tell me that it's an anomaly? So we were thinking, okay, how can we provide evidence? So we have a score, very high score, so it is very likely that this row of a data set is an anomaly. What does a user need in order to really verify himself or herself that it is an anomaly? You have to go back to the input data, right? Because only with the scores and the row number we cannot know if it's an anomaly or not. So our solution was, okay, if you see the input as well, then you will be sure that it is an anomaly. But then 2 problems appeared. So which column of the row is an anomaly then? Because we only have 1 score, and if I have a data set with 50 columns, and if it's not the price, maybe it's the exchange code, or maybe it's the quantity, how do I know? Should I check every single column? And the second problem was, if I only have the 1 input row, and I don't compare it to the rest of the input, and I see, for example, a price of 40, I don't know all the products. I cannot say if a price of 40 is good or not. I cannot say if this is the correct exchange code for this product. So what we did is, we started using Tableau. And our setup currently in production looks something like this. It is a bit more complex than this, but I think this is sufficient to get an idea. So in a Hadoop cluster we have a lot of data. So we input the data, then we have a pre-processing step where we normalize the data and so on, because otherwise the machine learning code does not work. Then we use 2 libraries, those 2, in order to predict the anomalies. Then we have the output, we put it back into the Hadoop cluster. From the Hadoop cluster, we go to Impala. With Impala, which has a direct connection to Tableau, we can access the data, we can show it to users. The user can actually give a feedback. The feedback will be written from Tableau back, that is not true, from Tableau to a Google Sheet and then back to the Hadoop cluster. And then as an input, the next day it will be used again for the data set, so that the model learns from the feedback of the user. In case we will have a false positive. So then some other details on it. I mentioned some of them before already. So we use Impala on top of Hadoop, so then we can just connect it to Tableau really easy. Then on the authorization side we use Kerberos and then also ForTruck. And we also have more specific permissions set on project levels within Tableau Server. The tables and views in Impala are maintained by our big data team, so that is also really nice to have dedicated people who can do this. And we have data stewardship, so that where we use Cloudera Navigator, where per department a data steward will describe the data and will always be available for questions if someone doesn't know what they look at. So then I have another quote, this is my boss. He actually says that only with Tableau our machine learning project became a success. And now I want to show you why. So this is the dashboard. It is with demo data, so that's why you see only a few rows in here, but I think it is good enough to just give an example. So what was important, because we always visualize the machine learning output together with the input, we had to kind of separate them. So everything in the dashboard which is red is from the machine learning output. Everything which is blue, that will be further down on the dashboard, is from the input. So whenever a user looks at it, it's red, the user knows, oh, now I'm looking at the score. If the user looks at something blue, the user knows, oh, now it's actually the data which we use as an input. So on top of it, we have some KPIs. Then, because it's a quite complex story behind it, whenever someone forgot how to use this dashboard, we have some kind of light bulbs here where everything is described and where you can see and read again how this works. And then the interesting part starts. So here you can select how many scores you want to see. So let's go a bit more down, because today I have a lot of other work to do, so I only want to check 21, the first 21 scores. And then, of course, I will select the first one first because it has the highest score. And this problem, what I described before, is solved with this second one here, because here we added to our code that we will also see a score per feature. So this dashboard shows what is driving the score here on this side. So I select the first one, this dashboard will adjust, and you can see, oh, this is mainly driven by the expiration of this product, because this is also from this price feed data, what I said before. So then, because not everyone wants to create dashboards, they want to have something which is already ready-made, you can select the main driver. So you say, okay, expiration, and then a dashboard is being created down here. So now you can compare to similar products with, for example, the same symbol or the same exchange, what are other expirations. And then I can see here, okay, it's from 2018 up to 2024, and then there's only one product, the highlighted one, which is 2080. So it looks already very suspicious. So I think most people who use this daily can say, okay, this is an anomaly. But if you are not very sure, you can still create your own. So let's take here another example. On this axis, it is just a row number. And then we can select, for example, the price. And then I can see here already, oh, here's one really high up here, but I still have the whole data set, so it doesn't tell me enough. So I say, okay, I want to see it only for stocks. So now I see all the prices of the stocks, and one is here. So I can be really sure, pretty sure that this is it. Or I can still say, okay, this is symbol, something with V. This one, oh, sorry. Okay, now it's only one left, so now I'm again not sure anymore. However, in the real data you have so much data points that it will probably not happen. But if it happens, here's then the last part. So this was row ID 152. That's actually the one which I typed in here before. So you type in, as a user of this dashboard, you type in the row ID number, and then it asks you, was it an anomaly? And then actually with this one I'm not sure, because now I cannot compare. So I say, I leave it blank, and then we will get this feedback from the user, and then we can look at it. Maybe we can improve the dashboard. So then we say, click to submit feedback. It will go to a Google document. It will be written here in a sheet, and then this sheet will be put back into the Hadoop cluster, where it will be picked up by the model the next day as a feedback, or also we can access it. I will show you later how this works, but I first want to show you something else, because if we just unselect this, what happened then was that we gave this to the users, and the user said, oh, this is really nice, but if an expiration is not what I expect, it's not a risk, because how I calculate the risk later on the model doesn't really use the expiration that much, so I don't care about this. So if this is the first one, I will waste my time on it. I don't want to look at it. I first want to look, for example, at the ones driven by the price, because the price is very crucial for our calculations. So therefore, we created the Sankey chart, and then here you see this, all the features again. You can select the price, and then you can see, oh, here this one, and we looked at it before. This one has actually price as the main driver. So you can click on it, and oh, it's only the third bar. So I already saved the time for looking at the first two, because now I can already immediately start with the third one. And then it works the same way. What we then also did is, just deselect this. We wanted to open up this black box of the model a little bit, because people, so they trust it a bit more since we have the dashboard, because then they can actually check the data and then they can compare. But they still say, yeah, but what exactly is this neural network? I don't get it. So we tried to visualize it a little bit. So here, this is basically the Latin space, this middle part after the compression happened. And what you can see here is all the data points, and most of them are here together in the middle. So this would be, for example, the zebras, because they are very similar. They were compressed in a similar way. Horses will be maybe here, and this will maybe be dogs or something else. And this is actually 3D. So you can rotate it in two different ways, and also around this axis. And then you can look at it from different angles. But in the end, you will still see, okay, those here are outliers and also those here. And then we can select one. And then this one is being selected. And then again, you can go down. You can say, oh, I forgot which ID it was. 4. Let's just assume 4 is an anomaly. We check this. We can confirm. So we say yes. And then again, it will be written to the Google Sheet. So this is the dashboard, and now I just wanted to show you how you can also write back data, first of all, and then secondly, how you can do this 3D rotation. So let's go here. No, sorry, back. So this here is all you need for writing something back. This is a little bit small. I put this URL in the presentation, so if you have the presentation later on, you can just read it there all. But for now, to give a quick... So here, what starts from here, is actually the specific part of the URL to go to the Google Sheet. And then here, this entry number, you can get also from your Google Sheet if you do right-click and then say View Source Code. Then you can search for entry. Then you see this number, like a different number, but in my case it is this number. And then you say, this number relates to this parameter, which ID. And another entry relates to the second parameter, and then submit. And this is it, and then it works. So this is one thing I wanted to show you. And then the second thing from here. So what happens here actually is 2 parameters with just numbers and steps. So you can increase it, decrease it, however you like. And the second one, and then there's calculations. For example, this one. And you use the 2 parameters, and then you will be able later on to show the parameters, and you will be able to rotate all the points. But also this calculation I put in the presentation. And this is it. So it's really not that much work, and I think many of my colleagues ask why doesn't Tableau support 3D? I think it's a good thing that they don't support it. However, in this case, it helps a bit because you can show what we usually show on a TensorFlow board. We can also show here. So you just have it in one place. So that's it. So going back to here. So here you can see the URL, what I was talking about. With this one you can create an action, and of course you have to open up a Google Sheet where you enter then 2 fields. In my case, if you have 5 questions, then 5. So this is this, and also you can read all about it here. And then about the 3D rotation, this is this one. So you have the 3 calculation, and then what you only need is the 2 parameters. But you can also read all about it here. So then, some words on mathematical world versus real world. I think this was a very crucial part in the dashboard. We wanted to combine the real world, which is in our case a data input, a data set. Mathematical world is the machine learning. People don't really understand it. They cannot grasp it. They don't trust it. If you think about your time in primary school and you think about learning division, I think at least for me it was the case that the teacher tended to say, you and your friend, you have 4 apples and you want to share them in a fair way. What would you do? And this is how I learned in the very beginning how I can divide 4 apples with 2 people, because that makes sense. Because there's a connection between a mathematical world, 4 divided by 2, and the real world. I have 4 apples and I have 2 people, so I want to divide it. So in the dashboard, we try to do the same. We have the machine learning, we have the output, but people don't work with that. People work with the data set. So that is why we try to make this link, especially with the color coding. And then this creates belief and trust, because this is familiar. This is something I know. This is something I can work with. And also regarding the 3D, what I said before, it's just a little bit opening up the black box. It's very theoretical. They have heard it many times, but it is not very clear, so we just try to visualize it a little bit, and it's getting better. It's still not 100% clear, of course, but there is more trust and more confidence in using it. Yeah. So, I hope I was able to show you the following things. Rule-based approaches are good, they work, but not always. So if they don't work for you, and if you have to add rules over and over again, maybe it is better to look for another solution. A neural network might be one. And try to create trust and belief in what you do. Because if people trust you or the product you have and believe in it, you will be more successful than if they don't believe it. And also the flexibility, I didn't mention that yet. The flexibility in the second part of the dashboard where you can build it yourself is also an important factor to the confidence of people. Because if later on you have to say anomaly or not, and you were not able to click yourself, but you just had the pre-built dashboard, it is still a bit sketchy. But if you select everything yourself and you know the data because you work with it every day, so you select all the same symbols from the same exchange in a specific time range, for example, then I get confident and then I can say, oh yes, indeed, this is an anomaly. I've never seen this. This is weird. Yeah, Tableau can write back data. You have seen that. But in the keynote, I heard that now this is all not needed anymore because now we can just use extensions. So good news. Maybe you don't even need my slides on the code. Yeah, the 3D, I said enough about it. And then I just wanted to say Tableau is awesome. I think it helped us enabling people a lot. And especially with the machine learning project, it was really helpful because I cannot imagine how we otherwise would have sold it to our users. If you have any questions about it or just want to give me feedback, you can reach me on LinkedIn but also on Tableau Public. And if you have any questions now, then feel free to ask. Yes, please. Yeah, there's the microphone, sorry.
A few questions, I'll just wrap them up into one, so they seem like one question. But how long from creating the model to rolling out the dashboard to your users did that take?
So we had this one person working on the model, and I think it was not really a problem of writing the code. It was more a problem of hardware. So we started, then we had to wait for better hardware, then we continued again. So in total, I think it was like half a year before we had the first output in a test environment. And then we went out and we said, okay, this is our result. And then everyone said, oh yeah, okay, whatever, I don't believe it. Then we started building the dashboard, which took maybe a month or so, like with working together and improving it and so on, yeah.
And then just follow on that, how many users did you roll out to? And is this kind of continual feedback period just indefinite, or do you expect to kind of close it off at some point?
Yeah, it's indefinite, but we hope so. At the moment in production, we use it only on a set of the whole data set because of hardware. So we are waiting now again for better hardware because it's just too much to process. So now we only take a part so that we can still continue working on it. Also, we have now production and development in the same machine, which is not really good because then if we have a new development, we wait again for another production output. So now we have maybe production output once a week. Then at the moment, I especially look at the scores, but I also go to the users, which is like a group of 10 people. And they then give me feedback more on the design. And at the moment, because it's not the whole data set, I only look at what are the highest scores. And is that something really an anomaly, or is it maybe something we can still improve in the model, which also happens? Yeah, but basically the feedback loop will be indefinite. But of course we hope that the higher scores will in the end be closer to the average than they are now. Yeah.
Hi.
Hi.
First of all, thank you. That was really useful. I have a question on more of a machine learning side, so choice of algorithm. If you kind of think of the scenario where you have your case where you need to communicate to a large amount of people and maybe not pick most complicated algorithms, I wonder if there's a particular reason why you picked using neural networks compared to clustering, so different, simpler, unsupervised methods that we use for anomaly detection.
Yeah, I don't know, because I didn't make the choice of the model, that really was my colleague. I think, because I know that we talked about clustering as well, but I think in his opinion it was not a good choice for what we wanted to achieve. But we are working now on something else where we actually want to try to cluster our clients. So then it would be more helpful to do something like clustering. But I cannot tell exactly why we chose this model.
Okay, thank you.
Yeah.
Thanks for the very nice presentation. Just have a quick question. After the feedback loop is closed, does the model get re-evaluated or retrained or not?
Not from the previous day, only on the next day it will be taken into account.
Yeah, but then the whole model gets retrained, or you wait for a couple of months and then re-specify the model?
So there's always a part of the data input the next day, which is for training purposes. But the initial training is, I think, takes longer. And then every day we use, like, I think 20% training again with the feedback of the model.
Okay, thanks.
I have two questions not related to Tableau. The first one, how long does it currently take for the model to train on the current hardware? And the second one, how exactly you making sure that these false positives are considered in the training and not appear in the report on the next day, because those are just few outliers. So how you make sure that they actually make influence on the model next day?
So what I said, I didn't write the code, but I try to answer as good as I can. So I think the calculation takes, for the training, takes at the moment a whole night. But I can also not tell you exactly what kind of GPUs we use. I don't know that. But the feedback. So if it's a false positive, then the model will be penalized. So it will increase the loss function, which the model doesn't want, because it wants to have to minimize the loss. And if it's a false positive, it will maximize it, then the model will try to do it better the next day. Yeah. Oh.
I was just, thanks first of all. I was just wondering, so apparently there are data issues in the input.
Yes.
So you use machine learning to detect them and to update them and to correct information. But what do you do to, because I think then you don't know actually why was that input wrong in the first place. You just correct it, but you don't know why it came in as wrong data. So is there also like an effort in how do we get the data in correctly at the first place?
Yeah. So this is everything about this data maintenance. That if everything is set up good, then we already decrease the likelihood of having anomalies. But it still happens for reasons we are not in charge of. Like if it's a data feed, and if there's an error in that data feed, we can call our data vendor and say, hey, here's an issue. Can you please look that this doesn't happen again, because it's then on their side. If it's on our side, then of course so I look for structural problems and I try to solve them. But if it's a problem from just a feed, which appears maybe once a day or once in a week, maybe once in a year, then we don't really structurally do something to prevent it. That's why we have now the machine learning.
I like this write-back feature through the Google Forms. Have you found a way actually to avoid that even this Google pop-up window comes in the end?
No, not yet, no. So I'm hoping now for the next upgrade, and then I will just use an extension.
Yeah. It's good enough for now.
Yeah.
Hi, one more question about the anomalies. I like the prioritization very much, and I think that was like the prime goal that you wanted to achieve. But of the other data, do you have some like goal also to identify the risk of anomalies that you didn't see in the remaining data?
That's a good question. So I don't think so, because then it's very difficult to say that it is an anomaly. So I will think about it. At the moment, I wouldn't know how we can then find those, because those are more the anomalies where we know we cannot find them, because of course still we have rules in place. Because it would also be a bit stupid if we would feed the model with known issues. Like maybe this is also a bit for your question. Like we still have in then our real risk model, we still do like exclusion of some things because we know it is wrong. But the ones we cannot detect, there we use this for. And if there's more in there, I will think about it.
So it's basically the second of third layers of quality.
Yeah.
Like the first is the obvious one, which you check rule-based.
Yeah.
This is the second one, and the last is just the last resort, which there is no actual solution to it, right?
Yeah.
Thanks.
Thank you. Okay then, thank you for your attention.